Now we're solving systems using substitution. This would be an algebraic method. These are the steps. I'm not going to read them to you. You can certainly read and write them down yourself. Some of you could probably do it in less steps, right? But I want to make sure I give you as much detail as possible. So let's take a look at an example problem. Okay, so example 1, we're going to solve this system using substitution. This system is set up perfectly for substitution because we have a variable already by itself. We know that y equals 6x minus 11. So we're going to take that y and we're going to plug it in, substitute it for the y in the other equation. That's the key idea. That's why it's called substitution. So I rewrite that equation, negative 2x minus 3, but instead of the y, I'm going to write 6x minus 11. Okay, now you'll notice my equation only has x's in it, and I can solve that kind of equation. All right, so again, the key idea here was I took this 6x minus 11 and I substituted it into the second equation in place of the y that was there. Now I solve. So I distribute. All your solving strategies here apply. Negative 2x minus 18x plus 33 equals negative 7. Don't forget that this is a negative 3 being distributed. That's why this becomes a positive 33. I want to combine like terms here, so that's negative 20x plus 33 equals negative 7. Subtract 33 from both sides. So I get negative 20x equaling negative 40. I divide by negative 20. So x equals 2. I'm only halfway done because I need to find y as well. So I take that x equals 2 and I plug it back into my original equation. It doesn't matter which equation you choose. I'm going to choose the easier one. Okay, and I'm going to plug the 2 in for the x. Instead of the x, I plug in 2 and I solve. So y is going to equal 12 minus 11. So y is going to equal 1. The final answer to a system of equations must be written as a coordinate. So my final answer then is 2, 1. Okay. Second example here, not as easy because we don't have a variable by itself. So what I'm telling you to look for here is a variable that would be the easiest to get by itself. This x has a negative 3, this y has a negative 8, this x has a negative 5, this y has nothing. Therefore, this y will be the easiest to get by itself because all I need to do is add a 5x to both sides. So identifying that is the first step, and I get y equals 19 plus 5x. So once I have y equals, and it doesn't have to be y equals, we could have been x, right? We could have solved for x. I'm going to take that and substitute it into the other equation for the y. So this is what it looks like. Negative 3x minus 8, parenthesis, and here's where the substitution happens, 19 plus 5x, and that's going to equal 20. Go ahead and solve that and then check back for your answer. Through solving that, I got x to be negative 4. And I'm going to take that x now and plug it back into either equation. I'm going to do this one, negative 5 times negative 4 plus y equals 19. That gives me 20 plus y equaling 19. And when I subtract 20, I get y equals negative 1. So my final answer, again, must be written as a coordinate. So that would be negative 4, comma, negative 1. And that would be the place where these two lines cross if I were to graph them from the previous lesson. One more example here. Okay, and this would be a special case. This could happen. I'm looking for the variable easiest to get by itself. It just happens to be the y again. I'm sorry, but it is what it is. So to do that, I'm going to add an x to both sides. I get y equals negative 3 plus x. I'm going to take that y and I'm going to substitute it in up here for this y. So I have negative 3x plus 3 times negative 3 plus x equals 4, and I solve. Minus 9 plus 3x, that's distributive property, and that's going to equal 4. Combine like terms. Oh, and I notice something happens here. Positive 3x and negative 3x make 0, which means there's no more x's in the problem. So I have negative 9 equals 4. If there's no more variables to solve for, this is a special case, this is a unique situation. I need to look at what I have left, negative 9 equals 4, and I need to ask myself, is that true? If it is true, there are infinite solutions. If it is false, in this case it is, there are no solutions. So these would be parallel lines if I had graphed them.